Good everyone, I'm Bhanuka and today I will be presenting our research, Broadening Our View, Assistive Technology for Cerebral Visual Impairment or CVI. CVI is the result of damage to the brain's visual processing centers rather than any physical damage to the eye. Current assessments mainly focus on ocular vision impairments, relying on criteria like visual acuity and visual field. However, people with CVI might have normal visual acuity but struggle with high-level visual functions. For example, a child with CVI might find it hard to identify their parent only when in a crowded room, or locate a specific toy when it is among other objects. Therefore, what should be considered when designing assistive devices for people with CVI? We identified four key criteria. First, people with CVI primarily rely on their vision. Secondly, people with CVI experience increasing difficulty as visual complexity increases. Next, assistive devices for CVI can induce permanent changes in the brain's visual pathways through neuroplasticity. Finally, CVI often co-occurs with other neurological conditions like cerebral palsy, which needs to be considered within the research approach. We define vision-based assistive technologies or VBATs as devices incorporating machine learning, computer vision, image enhancement, and virtual or augmented reality to enhance the quality of life for people with visual impairment. Considering the significance of vision-centric interactions for people with CVI, the question arises, can these technologies work as assistive technologies for people with CVI? For example, could we use this technology to fade out unwanted details when locating a pair of scissors or finding friends in a crowded venue? To answer this, we asked our main research question. What is the current state of research at the intersection of CVI and VBAT? And what opportunities exist in this domain? Our search identified four main findings. Firstly, only 14 papers were identified in the scoping review. This showed us that this area is under-researched. Out of the 14, only 3 papers focus on assistive technologies, with just one directly addressing CVI requirements. Next, people with CVI were primarily engaged in validating hypotheses or effectiveness of diagnosis. They were not involved in the design stages or requirement gathering stages. Finally, studies were also mainly done with children or young adult participants. So what can we do? With CVI said to be the leading cause of visual impairment and recent improvements in many of the technologies for VBAT, it is the right time to explore and investigate this under-researched area. We propose to bridge this gap from 2 key perspectives. Thank you everyone for listening to our presentation. For further details, we invite you to read our paper.